Here we have an infinite series with the expression 1 over 2n plus 1 times 2n plus 3, and I want to show that this infinite series converges to 1/6. And so this type of series is called a telescoping series. And so the first thing we want to do is decompose the expression 1 over 2n plus 1 times 2n plus 3. And we'll use what's called partial fraction decomposition to decompose this expression. And so in the equivalent expression is 1 over 2x plus 1 times 2x plus 3. And we can rewrite this as some constant a over 2x plus 1 plus some constant b over 2x plus 3. And to combine these two expressions, we can cross multiply. So it will be constant a times 2x plus 3, and then plus constant b times 2x plus 1, dividing by the product of 2x plus 1 and 2x plus 3. And then from here, we get 1 is equal to a times 2x plus 3 plus b times 2x plus 1. And this equation right here is true for all x. And so what we want to do is pick an x such that the factor here is 0. So for example, if we let x be negative 2/3, then negative 3 over negative 3 halves. And so because 2 times negative 3 over 2 is negative 3, and then negative 3 plus 3 is 0. And that's what we want. And that will help us get b. And so we'll let x be negative 3 halves. And so in the place of x, we have negative 3 halves and then negative 3 halves. And so to figure out, what x should be, just set 2x plus 3 equal to 0 and solve for x. And then we get negative 3 halves. And then here we get 0, and then 2 times negative 3 halves be negative 3. Negative 3 plus 1 is negative 2. So we end up with b equal to negative 1/2. And then same thing over here. Set 2x plus 1 equal to 0 and solve for x. And we get x to be negative 1. Okay, that's what we want. We want some x value. Make this factor 0. So in the place of x, we have negative 1/2, negative 1/2. 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0. 2 times negative 1/2 is negative 1 plus 3 be 2. So we get 2a is equal to 1. So a will be 1/2. So the expression 1 over 2x plus 1 times 2x plus 3 can be rewritten as 1/2, since 8 is 1/2, over 2x plus 1. And then b is negative 1/2, so we have negative 1/2 over 2x plus 3. And to get rid of the fractions up here, what we can do with this expression right here, multiply the top by 2, and then multiply the bottom by 2. And we get 1 over 4x plus 2. And then same thing here, multiply everything on the top by 2 and multiply everything on the bottom by 2. And we get negative 1 over 4x plus 6. And therefore our original series of 1 over 2n plus 1 times 2n plus 3 can be rewritten as the summation of 1 over 4n plus 2 minus 1 over 4n plus 6. And now let's form some partial sums. So this is the sum of the first 5 terms. And so we get 0.128205. This is the sum of the first 10 terms, and we get 0.14492. The sum of the first 100 terms is 0.1642. The sum of the first 1,000 terms is 0.166417. The sum of the first 10,000 terms is 0.166641. And the sum of the first 100,000 terms is 0.166664. And so we can see that as n gets larger and larger and larger here, the sequence of partial sums is approaching 0.016666, which is 1/6. And now let's write the sum of the first k terms. So here are the first 5 terms. This is the kth term. So in the place of n, we just have k. The term before the kth term, in the place of n, we just have k minus 1. And before that, we have n as k minus 2. Here n is k minus 3, k minus 4, k minus 5. And then simplify. This is what we end up with for the sum of the first k terms. And then right here, we can see that minus 1/10 and 1/10 will cancel it out. And these will drop out. And then the same thing here. And then eventually, and then these will also drop out. And this term eventually will get dropped out also. So what's left is the 1/6 minus 1 over 4k plus 6. So the sum of the first k terms is 1 over 6 minus 1 over 4k plus 6. This is the original series. And then this infinite series is the same as the limit of s of k as k approaches infinity. So we can see that this is the sum of the first k terms, but if we let k run to infinity, then we get the entire infinite series. And so the infinite series is the same as the limit of s of k as k approaches infinity. But s of k, which is the sum of the first k terms, is 1/6 minus 1 over 4k plus 6. As k approaches infinity, this term here approaches 0. So we get 1/6 minus 0, which is 1/6. And so here we say that this is the original infinite series with the expression 1 over 2n plus 1 times 2n plus 3. It converges to 1/6. And that's the end of the video.